Good afternoon, everyone. Now we are going to tackle about 20th century mathematics by G.H. Hardy and Srinivasa Ramanujan. But before that, let's engage in a short game activity. Here are the instructions. This activity is called concube. I will divide the student into two groups. The task is to find the correct answer of the given number. I hope in 60 seconds, all tasks are finished. Finish. Now let's have the key to correction. 12 raised to 3 plus 1 raised to 3. 12 raised to 3 is equals to 1728 and 1 raised to 3 is equals to 1 because 1 times 1 is equals to 1 times 1 is equals to 1. 1728 plus 1, the final result is 1729. Next, number 2. 9 raised to 3 plus 10 raised to 3. 9 raised to 3 is equals to 729 and 10 raised to 3 is equals to 100. 729 plus 100, so the final answer is 1729. Now, what did you observe? The answer is the same. Excellent! As you can see, 1729 is called Hardy and Ramanujan number. According to them, it is the smallest number which expressed as the sum of two different cubes into different ways. In connection with the activity, our topic is all about G.H. Hardy and Srinivasa Ramanujan in 20th century mathematics. For today's discussion, here are the following objectives that everyone must attain at the end of our lesson. Objectives: A. Identify the major contribution of G.H. Hardy and Srinivasa Ramanujan in 20th century mathematics. B. Explain the significance of contribution of the field of mathematics. And C. Evaluate the influence of 20th century mathematician on shaping mathematical thoughts. Now, let's proceed. G.H. Hardy was a prominent British mathematician, while Srinivasa Ramanujan was a self-taught mathematical prodigy. Himself and the Cambridge scholar was instrumental in recognizing Ramanujan's genius and securing him a scholar to study at the University of Madras and later at Cambridge University, which led to their famous collaboration from 1914 to 1918. Godfrey Harold Hardy, or G.H. Hardy, is an English mathematician for his work in number theory and analysis, with his collaboration with mathematician Srinivasa Ramanujan and John Edensor Littlewood. So, as we can see, Srinivasa Ramanujan is not the only one to which Godfrey Harold Hardy collaborated in the field of mathematics. G.H. Hardy was born on February 7, 1877, while he died on December 1, 1947. He was known for the contribution to pure mathematics, the Hardy-Weinberg principle, and genetics, and the essay that which we called A Mathematician Apology. What do you think is the context of Hardy's essay? So, this is the Mathematician Apology. A Mathematician Apology is an essay that contains the following: the beauty of mathematics, the contrast of pure mathematics and applied mathematics, mathematics as a young man's game, example of mathematical beauty, a personal autobiography, and discussion of mathematical reality. Ngayon, pag-usapan naman natin si Srinivasa Iyengar Ramanujan or Srinivasa Ramanujan. He was born on 1887 and died on 1920. His works focus on infinite series, prime numbers, and continued fraction. He began to publish papers in 1911. He had delicate health throughout his life and suffered from tuberculosis, returning to India in 1919, where he died at age of 32 in 1920. According to what we have read, Srinivasa Ramanujan has suffered tuberculosis. Do you think this health problem influences his contribution? Okay, as we can observe, plus, that Srinivasa Ramanujan created a bigger impact and history in the field of mathematics. So, ibig sabihin, yung health condition niya, hindi nakapag-influence sa contribution niya. G.H. Hardy and Srinivasa Ramanujan contribution and legacy. Hardy's key contribution. Number 1, formalization of Ramanujan work. Hardy recognized the genius of Srinivasa Ramanujan and worked tirelessly to formalize and publish his work, introducing it to the Western mathematical community. Number 2, mentorship. Hardy mentored Ramanujan, helping him refine his ideas and theorems and bringing his work to international recognition. Number 3, collaboration on other projects. Hardy collaborated with G.E. Littlewood on numerous projects, including work on number theory, mathematical analysis, and the development of the Hardy's Littlewood circle method. And the last one, number 4, Hardy-Weinberg principle. Hardy, along with Wilhelm Weinberg, formulated the Hardy's-Weinberg principle, a fundamental concept in population genetics that describe how allele and genotypes frequencies remain constant in a population over time. Ramanujan key contribution. Number 1, number theory. Ramanujan made significant contribution to number theory, including the development of highly composite numbers and the study of partition function. Number 2, partition function. His work extensively on the partition function, which represent the number of ways a positive integer can be expressed as a sum of positive integers. Number 3, Mach modular forms. Ramanujan work on Mach modular forms has had a lasting impact on number theory and continues to influence research today. Number 4, Hardy-Ramanujan asymptotic formula. His collaboration with Hardy to the development of the Hardy's-Ramanujan asymptotic formula, which provide an approximation for the number of partition of a large integer. Okay, as we go further on our last slide of discussion, the enduring legacy of their collaboration. The synergy, the 1729 anecdote, the enduring impact. Number 1, the synergy. Synergy refers to the powerful combination of Hardy's rigorous formal mathematical training and Ramanujan's extraordinary intuitive group of numbers and patterns. Their partnership bridged different mathematical traditions, enabling breakthrough in areas like number theory, modular forms, and infinite series. The second one is the 1729 anecdote. This is the activity that we answer kanina, di ba? So, the 1729 anecdote is a famous story where Hardy mentioned taking a taxi with number 1729, calling it dull, and Ramanujan immediately noted that it was the smallest number expressively as the sum of two positive cubes in two distinct ways. This illustrates Ramanujan's unique mathematical insight and has become a symbol of their collaboration in mathematical curiosity. And the number 3, the last, is the enduring impact. Their work laid groundwork for modern research in multiple mathematical fields. It also highlighted the value of cross-cultural intellectual exchange, inspired generation of mathematicians, and elevated global recognition of Indian mathematical talent. That's all for today. Thank you for watching, and I hope you learn. Goodbye!